Hello everyone. So thank you for the opportunity to present my approach to this project. So my name is Rémi Sablier, and I will be working with my coworker Yuki-chan to build a backend for a group to-do application. So we work together most of the time. So the task is to create an efficient API for managing task, user, and potentially other resources, also project, like Jira or Trello. So first, as with any project, we will start by understanding the requirements and designing an effective database schema. And once the schema is defined, we will use Next migration to create the database. Next, we will move on to building a RESTful API with an Express server. And each route will have a specific path and perform an operation on a specific resource. So throughout the process, I will focus on writing clean, maintainable code and error handling. So then let's dive into the design and begin implementing the backend. So when we start to build a full stack application, like a backend application, we always start from the beginning, meaning from the database. So we have to understand the need, and from the needs, we create entity relation table model. Then we can create the table, define the column and the dependency between the tables. So when we create a backend database, basically we talk about database normalization. It's important because it reduces data redundancy and improves data integrity. So there are a few database normalization norms: 1NF, 2NF, 3, 4, 5NF. But the higher the normal form, NF means normal form, the higher the normal form is and stricter the rule becomes, ensuring that better data integrity and reducing integrity. However, to achieve a higher normal form often result in more tables, which can negatively impact query performance due to the increased number of joins required. So it also increases the complexity and the maintenance. So there is quite a good enough normalization standards which is called BCNF, which is Boy's Code Normal Form, because it ensures that all functional dependencies are properly aligned with candidate keys, eliminating anomalies and ensuring consistency. So basically, you will have one key for a set of value going together. Not everything, every value will have a unique identity which gonna be the key actually. So this is what the BCNF normal form ensure. So now we are going to start designing the model. So we are in the world of AI, so we are going to use AI to save time because we have only like maybe 1 hour to make a whole project. So we are going to use AI. So basically, let's ask what we want. So provide me, let's start. Provide me an entity relation diagram for a to-do application of only 3 entities made of user, task, and projects. So basically, this model must comply with BCNF. Table IDs must be UID. So I want to keep UID because it's a global identifier. When you have several systems, you want to avoid your IDs from different tables or systems to conflict together. So we use UID, which are really unique, whatever the system is, it's global. And that's a good practice to use this kind of field for ID as an ID. So I want you to, we will name them, I want you to name them ID because it's more convenient. So we will have 3 entities. For this first part of the project, I will focus on project, task, and user. So basically, use a user on a project. You can have several tasks assigned to a project. A project is a task is assigned to a project and to a user. For comments, commenting on the task, which is a basic functionality for a to-do application, this is not going to be part of this project because it's a question of time. It's like going to create a lot of it's like kind of a lot of features to add later on. We are just creating a basic to-do application. So for example, for the project table, so basically we want the name of the project to be unique because we want to prevent several projects to have the same name. So we want the name to be unique. For the user table, we want, of course, we want the email and the username to be unique. And for every table, we want to have a created hat column because so that we know when those data has been created. Every users table must have a password, and so also provide for every column of those three tables, three entities, standard type in terms of like string, datetime, number, enum, etc. So this must be easy to read and copy pastable within a MD file. Let's see what we have. So it's going to be something like it. He added some information I didn't need, but yeah, basically we have something that looks like what we are going to implement. So the good point with so we are going to create a doc in our project actually we are going to document it as much as we can, and because AI is really convenient, we can generate things that would take a lot of time manually and just save as side documentation. So for example, entity relation.md, and we can reuse, for example, this. And so I will apply a few modifications later on, just to give you an example of how to use AI, how to create documentation quickly, or to start a project. Most of the time, when now we are in the age of AI, so we use AI most of the time. AI is good to confirm choice, to save time to make like repetitive task, and it's like a co-worker. Like we work together. You challenge the AI to make something that works, that fit what you need, because from scratch, AI won't be able to give exactly what you need, right? You will need to give him more information, change some output format and stuff like that. So it's basically you work a lot with AI and you build your application along with. So now we are going to start working on creating our database with Next. So first of all, I have initiated the database, a Postgre database within Docker, using Docker Compose. So instead of installing Postgre directly on my laptop, on my Mac, I have created a container with Postgre in it, so that I don't have to install several like application on my own laptop, and this container can be used everywhere in every environment. It's not environment dependent. So we could actually use it to deploy on AWS or someone else's computer, actually. Really convenient. Also, I use PMPM. On this project, I use PNPM and not NPM just because all the libraries are globally stored and it's better, it's more efficient, even though some issues appear sometime with Node.js, with some libraries, but it's quite robust enough, and especially for this case, his use case is gonna be enough. It's gonna work well. I have already no, we don't need this one. So we are going to use Nodman. Nodman is a library to, whenever you update your source code, your backend API, it will update automatically and restart the server. So it's really convenient when you develop. So using Knex, we are going, this is the Knex configuration. All the environment variables are stored in a .env file that I already created. And now we are going to create the migration. So basically we are going to create the table. So let's start by creating the table. So of course we could create Knex file using what you did before. But if we do so, I will never code anything. I will keep asking the AI. So let's try to type some code by myself. So basically, let's start with one table. Huh? So first of all, we have three tables. We have user, projects, and task. Let's start with actually the user. So whenever we create, let's have it clear. We start by we use the Knex schema, and then we will start creating the table. So I realize that actually my keyboard is not working as expected since this morning. Maybe because I was in Japanese, that's why. So basically, let's create a table. Name is gonna be users, and we are going to. So inside this table, we are going we are going to define our column. So first of all, we are going to create an ID column, which is a UID type, and it is a primary key. And I wanted to actually, so whenever we insert in the table, we want the row to be like the ID to be automatically generated. In this case, we are using UID, and with Knex, in order to leverage UID, there is a plugin to generate those IDs, which is UID generate before. Voilà. Étonné. Voilà. So this is going to be our first column, and then we are going to create, not UID, but it's gonna be string. It's gonna be username. So because it's string, we are specified. So I asked already the AI what length will be standard for username. So 30 is good enough. It's a unique field. By default, primary is unique, so we don't need to specify it. And it's not nullable. We need it. We cannot have a user without a username, right? This is going to be okay for the username, and then we are going to do the same for the email. And not nullable, the password, which is about 255. And at the end, we are going to created at, which which is we don't. It's just not a string, so we don't need to. Actually, it's a timestamp. Sorry, and not unique. This is also not unique, and this one is default too, and it's gonna be alright. Then we are maybe good with our user table. Also, in order to improve performance, you have to consider index, right? Because it's not only the primary key, we are going to make some search based on other column inside the table. By default, primary key are always indexed, but not all the other columns are not. So in the logic I will implement, we will make some search based on the username. So we also need to have an index on the username to increase performance. So the index will increase the speed the way we are looking based on this field. However, whenever you insert new data in the table, it will have some time, because every time you add a new line within the user table, you will have to create or adjust the index for the username column. So it's not good to have too many index. You have to consider which column you should apply an index to. So let's say now we have our user table, and we are going to do the same with the project table. So basically this is a project table. We have ID, which is actually the same. Here we are going to have a name for the project. The project name has to be longer, unique, not nullable is good. We are going to have a description for the project. It's gonna be nullable. We are going to have owner ID. So we are going to have a foreign key based on the user table ID. So whenever we want to, for example, delete a user and there is a project, we are not going to actually be able to delete the project. However, we can ask actually to, whenever we delete a user, we can ask to automatically delete the project as well. But even though it's not a good practice at all. So user ID is unsigned and it's not nullable. We have a created hat, of course. We will have an index on this owner ID. And now we are going to create, so this one is index. And we want to create our foreign key. And this one will be, so I need to go in like capital letters. And now we are going to create foreign owner ID. So we specify the reference, which is ID on in the table users. So we want cascade, meaning that whenever actually we are not going to add cascade. Okay. Let's see later if we need to use cascade actually. Cascade, which means we are going to delete automatically a user. Whenever the user is deleted, I would say the project will be deleted, which is, I don't think it's a good idea. We just want to assign the project to someone else. Now let's consider we're going to create the task table. So this one is gonna be a bit more complicated. So basically we have a task table, ID, and we generate UID, global ID. Then the task will have a title made of 250 characters. I don't task name doesn't have to be unique, but it cannot be nullable. It should not be nullable. It should not be nullable. Yeah. Then description nullable. Alors, here we are going to have a new type, which is an enumeration. So for the status. So basically, we will have a status for every task. And whenever status are predefined values, so we will have, for example, pending, in progress, and also completed. It's gonna be default to pending. By default, when you create a task, it's gonna be pending. Then we need so for example, a task, we need a due date when we want the task to be delivered. Timestamp, so due date will be a timestamp, and it's gonna be it's gonna be nullable. Sometimes we don't want to specify specifically a date, right? Like it is for Asana or Jira. Then we are going to specify a task is assigned to a project, so we need to specify the project ID as a foreign key inside our task table. So we are going to create this project ID, which is a UID. It is unsigned and it is nullable, even though unsigned was not necessary, not nullable, sorry. But it's actually a foreign key, so we must have a project ID within a task. And we are going to do the same with the owner ID. Actually, it's already here. I don't need it. And then we are going to index the owner ID and the project ID, because we at some point we will have to make some join and those on this column, so it's interesting to have an index on them. So we need to specify the foreign key. So first of all, actually it's not going to call you owner ID, but user ID. The owner ID maybe is good enough. Owner ID, which actually reference the ID in the user, and we are going to create the project ID foreign key, which is based on the ID on the project table. Here we go. Maybe that's I should have installed Prettier because it doesn't auto format currently. I will clean it up later. My auto formatting is actually not working with it. I think it's because Prettier, I didn't install Prettier on this project. So now we are going whenever you create a next migration, you have the up and down function. The up is to create something to migrate, and down function is to remove what you actually created. So here we create suitable, so we are going to delete the suitables whenever we want to uninstall or start from scratch. Tasks, and then we are going to do the same for users and projects. Ja, good enough. So now let's actually create a database. So this is actually my to-do app on Postgre that I'm hosting on my container Docker. So as you can see, I don't have any table, and I'm going to migrate the table. So basically, voilà, we run one migration. Let's check, and we got our tables. So now we have the table. We need to generate simple data for the purpose of this proof of concept, for the purpose of this project. So when you want to save time, we are going to use AI. So basically, I would say to the AI, I'm going to use the connects migration, for example, and I would tell the AI, I will copy paste it. Could you generate me some data samples to insert within this table as seeds? About 3 rows per table would be about 0 to this. So it's going to generate the samples that actually we are going to reuse directly in our seed files that I need to create. There we go. So now we are going to generate those lines. For that, we are going to run papernote seed directly. Did I save the file? Not sure. Yes, I did that. And we run the seed files. Now let's check in the database if we have the files, the data. So check here. We have 2 lines. I didn't create it. We have 3 users and 3 tasks. That's enough for what we want to do anyway. Then we are done with the first part of this project, which was actually creating the database, creating the model, the database, and inserting some data. Now we will go and talk about implementing really the API. So now now we are going to talk about the model. So whenever we create a backend API using Express or whatever, like maybe Nest.js as well, basically we have what we call a model, and a model acts as an abstraction layer between our application logic and the database. So instead of writing raw SQL queries everywhere, we are going actually to create models which are a bundle of queries, but not SQL. It's gonna be Connect queries. It's convenient. You don't have to create SQL queries, and it prevents SQL injection actually. So it's good for security purpose to use libraries like Next. So we will use these models to manage data retrieval, insertion, update, and deletion in a structured way and reusable way. So by centralizing all database interaction inside models, we make our code cleaner and easier to debug. So we have a model. Let's close all. We have a model new folders, and we are going to create the model for our user table. So let's start. So we call it model.ts. And now as a code, I will create a model for the user table. I'm not going to do for all the other tables because it will take a lot of time, and we are going to leverage AI to actually take example on our user model and just leverage what we did to do the same for other tables so that we save a lot of time. So let's start and let's start. Let's go. So now we are going to import a Knex from the Knex library. So before going forward, we are going to create types. So my project is made using TypeScript. I don't do any JavaScript only project anymore. So I have incorporated TypeScript in the needs actually. So we are going to create a new type for the user. It's gonna be real simple types, no worries. So we are going to have a user type, and this user type is actually, now we are going to need an ID. I make it optional, but it's not optional, no worries. It's just for later on you will understand. We need a string. The API itself doesn't need it, but the ID will be auto-generated, so the type is actually optional. An email, a password, and then we are going to create the created at, which is actually a string, even though it is this colon is that time it is actually a string. We can convert it back later on. So let's start with our user table. We go back inside the model, and we are going to import our type. I have created a specific alias to directly go within my project types folder, so that it makes the import more cleaner. Every type we use type so that we know it is a type. I always separate my import. This is the libraries, this is types, and then I will import components or whatever, but by group together, so that when I look at a file is clean. I know where to look right away. So now we are going to import our Knex instance. This is inside DB file. The Knex instance is generated here. We import the database configuration, and we instantiate it, and we make it available to the model so that it can make operation on the database. So now we are going to create a class. So you can make a module or a class, whatever. The important point is to keep things together. It should be a modular. So it makes maintenance easier. We are going to have a user model, and within this user model, we are going to have our Knex, which is going to come from the the private Knex. So this is just a class. I didn't actually yet created. So we are going to create the constructor. It is a class, so there is a constructor which is of type Knex, and we are going within this we are going to actually get assigned to our local variable the Knex coming from the constructor. The function that calls the constructor will provide the Knex instance. So this actually the reason why there is because the Knex I mistaken actually his name. There is a capital key. So now we are going to create a function. So we will create a few functions. One function to get all the users, two functions to create a user by ID, one function to create, one to update, and one to delete the user. So let's start. So first of all, let's say we are going to is going to be, so those are promise and it's asynchronous code. So that's why we have, as soon as you specify async in your function, the function itself will return a promise. We have to specify it. It returns a promise using TypeScript, and basically we say to Knex, please get me the value from the table and get all columns. Here we go. Then we are going to create a function for get user by ID. User by ID. So ID will be provided as a string, and it will return. This is a user, not a small user. Let's say we are going to return a promise of user, not an array of user. And for example, we say this point next we get from the user table, and I would like to get where this is a conditional, where the ID is where actually we specified the ID actually as a parameters, and we take the first. If normally there is no two, but just in case of, we make sure that we only have one value coming back. And we say you return the user or null because potentially the user doesn't exist. So get a user by ID. So those are really simple functions. The name are clear. So for this kind of case, we don't have to create a huge JS doc. Well, we could do it at the end for production purpose, but for the purpose of this this interview, I would not create like full JS doc. But at the end, in a real application, I will of course create as much documentation as possible because it makes the maintenance easier. So now we are going to create a new user, and for this purpose, we are going to create user. We have an ID. We need a create user. So we need a user object, but the user object it will not have all the columns because, for example, the ID will not be included because the ID will be generated by the database itself, right? So we are going to have what we call a partial user, meaning we don't have all the properties of the user within this user. This is a way to also prevent TypeScript to throw an error. So it's gonna be either user or null. When you create a RESTful application, whenever you modify resources, you have to, the good practice is to return these resources once created. In the case we didn't succeed to create the user, we are going to, actually we are going to create a user without any issues here. No issues. So basically we say to, it's gonna, because when you, by default you create an array, we are going to create an array for this user. So we are going to say to Knex, please insert the user and returning everything. This. Now we have created our user. I don't know why I don't need the ID. We just need the user. I don't know why the user. Now we are going to update a user and delete a user. So now let's create the function to update the user. To update a user, we need, like this time we really need the ID. We need they need the partial user. I'm going to use this one. And we are going to return, actually we are going to return this promise user, but potentially null. If, for example, we didn't find the user or something like that. So because whenever we do connect operation, it always return an array, but we are going to specify that we just want that we know there is only one instance within the array. This is a way to actually fetch the value within the array and return it. Make things cleaner. Alors, I would like where the user is ID to update the user, and also please return everything because we are on a RESTful application and we want to apply good practice. It prevents returning the updated resource prevents in some configuration, some case, to the front end to fetch again all the values, all the data. We return him the last up-to-date values, so that we don't have to do a greedy fetch of all the resources again. It's just to improve performance and reduce the workload on the server side. Alors, I want you to return either the updated user or please null. So just for information, based on the case, like currently I'm not using GitHub Copilot, but I sometimes use it. If we use GitHub Copilot, basically it will drop everything for me. I'm not coding anymore. So I like to code also a little bit myself, and I like to actually challenge ChatGPT directly. I also have ChatGPT integrated directly in my VS Code environment. But the ChatGPT requires to pay money, like to get like tokens. So I use it when the project is in rush. I will use my tokens to directly develop and quickly, for example, debug, fetch for information. It's gonna be convenient to have ChatGPT within the working environment. Otherwise, I will most of the time use ChatGPT outside like this to challenge and to ask questions, so that it allows me also to use my own brain, because if we only use AI, we forget to use our ability to think. That's the problem with AI. So now I'm going to delete the user. It's gonna be an ID string. The promise is actually this time it should be and so whenever we delete, we return the number of row deleted. We return the number of row deleted. No, this is not what I wanted to do. I want to actually deleted count. We need the ID, and we're going to delete it. Here we go, and we return the deleted count. Here we go. For the purpose of this API, at some point we also need to find a user by email or by password. It will be required at some point. So I'm going creating a specific model function for it. So for example, we have the email, the username, and it will return either a user or nothing. I know this pop next. I want to check when the email is email or where the username is username, and I want to get the first one because it's always sending back an array. I could have used first before also. So what I have here, I know I have my email. Here we go. Now we are done with our model. I will add comments above the function later on. And at the end, so this is just a class, right? Now we need to instantiate the class, right? So we are going to create a new with the next instances we created on earlier. We actually generated and imported from here. Here we go. So now, so we have successfully built a model that acts as a bridge between our database and application logic. So next we are going to integrate it in our API routes and see it in action. So now, before we dive into the implementation, let's talk briefly about RESTful API. So REST stands for Representational State Transfer. It's an architectural style for designing network application. So it relies on a stateless client-server communication model, where each interaction between the client and the server is independent of any prior or future interaction. This makes REST API scalable and simple to maintain. So in REST, not this one, let's east. So in REST, we work with resources. So in our case, resources are our table, like our user, task, or project. And we can call them entities also, resource entities. And each resource is identified by a URL and interact through standard HTTP method. So our API will allow us to perform CRUD operation. So CRUD operation means actually create for the C means create, read, update, and delete. For example, for this one we use HTTP method get. For this one, this create is post, read is get. For update, we are going to use patch or put, and for the last one, delete is gonna be delete. as simple as it is. Each request to the server is made based on one of those method, and we will ensure that the API operates in stateless and uniform manners. So for every of the routes, basically we have to ensure that we ensure proper validation. We need to make data validation on the input, on the value provided by the caller, so from the front end, for example. And we have to ensure error handling. So basically, and I should have explained it before I start the model, but we have, when we create a RESTful API, using, for example, Express server, basically we have a few things to talk about. We have, for example, we have our server, which is the base, right? The server is the entry point. The servers will actually define routes. The routes, let's say like this. Routes actually just based on the path of the query, the URL path. For example, /API/users. We know that these routes have to go to this direction, has to call this controller. So the routes will make the relation between the request query, and the controllers. It will, and then the controllers is responsible for handling the incoming HTTP request, and it is also responsible to returning a response to the client. So basically it will perform data validation on the input. It will also handle errors. In his goal also will to call the next step in the chain, which is the service. The service is the business logic. This is where you have all the logic. The service sits between the controller and the models. It can involve multiple models. For example, whenever you want to make an operation on a project task, for example, you want to make sure the user and the project exist. So you will actually check for the presence of the project and the user, even though you are in the task service. And finally, we have the model that we already created for the user. This is relation with database, perform queries. Data validation and routing based on the path of the URL request. Here we go. So now we are going to start. We will implement the service layer, the service, because we already implemented the model for the user. So let's start with the service. Now we are going to create a service for the user. So within this service, we will need a few things. First of all, we will need the type of our user. We need, I already created them because otherwise it would take a lot of times. So I have created specific database related errors, conflict error, not found error. And this comes from our error folders. Now let me talk about it. we have a error folder here. Whenever we to keep import clean, most of the one of the best practices is to create an index file and where you export everything from this folder, so that instead of importing from custom error or from DB error, we just import from error, makes the code cleaner. So here is my DB error. So I have created a few type. I have generated using AI a few type of regular database related errors. For example, unique violation, foreign key violation, stuff like that. Then in the custom errors, this is just a way to create an object, which is an instance of error. And whenever we handle errors in RESTful API, we have to handle the error code, which are for bad request 400, unauthorized 401, 3 forbidden errors not found 404. Internal server errors, which is 500, and conflict error 409. So instead of creating every time a specific error in our code, we just have in a single place we create the definition of those errors, and we can reuse them whenever we need. So let's go back to our user service. Inside our service, we will need also the user model we just created, which is actually like this. Controllers. Alors, also same for here within the controller, which is here. I need to create a file which is for example index.ts. Then we are going to start creating our service. So basically we are going to call the different actually no, user controllers. We're going to call the different function that I was thinking about the controller, but actually it was a model. I was actually mixed up in my head. We're going to call the different functions coming from the model, and for this we also need to create an index file, export here we go. Here we go. So we will have a function, a root, whose purpose is going to send to provide all the users. So we are going to create this function. Modal de Vanai. Okay. And this one is here. Oh, here we go. We have our first function. Now get user by ID. Yes, it's a promise of user. Here we're going to call our function that we created earlier, which is get user by ID, and we are going to provide the ID. In the case we do not have any user coming back, we are going to throw an error which is not found error. Please return the user was done. Next, we are going to create the user. We are going to implement a function that create the user. Alors, here, when we create a user, now the user will have to specify his password, and the password, we cannot store a password like this directly on the database for security concerns. We are going to hash the password. So in order to hash the password, we are going to use a library called bcrypt. So let's go to util, and we are going to create a new file called bcrypt, and within it let's import our bcrypt library, mistaken in the name here. And basically, whenever we hash something, we add something, we specify something we call the salt or runs. You can call runs also, and basically it makes the hashing more difficult to be found. Actually, it's like it improves the hashing actually. So we add the salt of 10. And then we are going to hash it, hash the text we provided with the salt as second parameters. Now let's go back within the service. So this because we are going to throw and we have to handle also some exception here. So we are going to create a try catch block. First of all, let's hash the password before storing. Then hash text, I forgot to import actually. What was the name of the function? I forgot to add. Okay, we have our hash text function. Now we are going to create the user. Create user. We are going to provide our user, but for the password, we are going to provide the hashed version of the password. This. And then there is an error. So we are expecting the user. It is possible that the user already exists. So we are going to create. We are going to handle exception in this case properly, because the database exceptions are not really friendly in general. So we are going to implement with our own errors handling. The next the next instance, whenever there is an error, will send back will throw an exception, an object with a code within it. And the code actually is a code we actually defined earlier in the error files. And this time is unique violation, meaning there is so here the thing is that, for example, you remember when you created the user table, we specified the username and the email of the users to be unique, right? So if we try to insert two users with the same email, at this moment the database will send back throw an error. And the thing we are doing here is to handle these errors nicely, meaning that we catch it, we are going to create a conflict error. This is one of the errors we have created earlier. If we go to the errors, custom errors, we have a conflict error here. And these guys will actually assign a message with a custom error code of 409, which is the appropriate HTTP error code whenever there is a conflict error. So we have to respect the standard of the HTTP request. And because the database API doesn't know about those concept of 400, 401 element, we have to handle it in our source code, right? So we are going to we are going to create it here. So conflict error, a user with this email or username already exists. Here we go. And we need to, otherwise, if we don't know what kind of error is it, we still throw an error. It will be handled at the higher level of our application. Here we go. We have created the user. Now let's let's update the user. Alors, let's go. No, let's first delete the user, sorry. So deleted count, this is a value which is sent back from our model function. There is no D here. And then see if there is no deleted count, then it means that the user has not been deleted and means it has not been found. So not found errors. Here we go. Otherwise, please return the number of rows deleted. It should be 1 every time. So now let's create a function to update the user. We have to go quicker because I know it's taking a lot of time, sorry. I'm trying to go through every step. We are going to update the user, meaning that first of all we want to see if the user already exists. If it doesn't exist, we need to throw we need to check if he exists, but no. We need to check if the new, like the email we try to update or the username we try to update doesn't exist already. Otherwise, it's gonna be a conflict error, right? So that's why we created a function earlier, which is find by email or username. If the user exists, please throw a conflict error. Then we are going to still a user exists, but the user could be the same user, right? It can be this so we have to make sure the ID is different, meaning it's different user having already this new username. Then let's do the following. Oh no, I forgot to assign function. What did I do here? No, it's not the wait, it's add sync, so sorry. User null. Okay, better. What about our username? Okay, let's continue. See if the user already exists and it is not the current user. In this case, please throw a new conflict error. Now we are going to check for the username itself. In this case, we are going to reuse what we did already. This time it's gonna be username is already taken. And after we have made those checks, we are going to return actually the user update, the updated user. We are going to call the update and return the updated user. There we go. So here, what do we have? Username. There we go. So we are done with actually our user service class, and now we are going to instantiate it so that the controller layer can reuse it. There we go. So I forgot to do it before, but we will have to actually commit our code little by little. So let's say, first of all, for example, during me, we are going to add Docker Compose. This is we are going to start with for example the project initialization. We will need no, there is a node module. We don't need the node module, so we are going to create a file, and this file will actually ignore the node module. Right, disappear. Now we are going to add the TypeScript config and the nodemon and the pnpm and our environment variable, our documentation. Actually, we need everything except the source file. So whenever I commit, I use a utility called gitmoji. because it actually allow you to add nice emoji in your commit, make it more clear. So you can select whatever you want, fix CI build, downgrade dependencies, whatever. So we have to find something that fits. Fix a bug, critical, update documentation, deploy stuff is like really random actually. I thought there is an initialization one. Adapted configuration file. Let's say configuration file. Development script. Alors, initialize the project. And here we go. Now we can check. We have our first commit here. And next one, we are going to add the all the things related to our database. So basically, it's gonna be the DB folder. Here we go. So Gitmoji. And this one is gonna be add configuration files. Add Postgre and Connects configuration. Here we go. We have already 2 commits with nice comments. So now the next one is going to be the model we created. Git add source model. And Gitmoji. This one is gonna be, we can say its features. This is the features. Implement models. And now we are going to add the service. Implement service. Now we have 1, 2. This is then add Postgre and Connects configuration, implement the model, implement the service. Yeah. Now the next step will be to take care of our controllers. So in regard to the controller, we are going to create the controllers for a user. So basically, this is where we are going to handle our queries. So just as a warm-up, I would say, like, the controllers are responsible for handling the incoming HTTP request and returning the response to the client. They use the services to perform the necessary operation. So in our application, the controller will handle a request like creating a user or listing all the tasks or whatever, and then return the success or error response to the client. So now we are going to work with, first of all, this type are the express type. From express. Then we are going to import or not found errors, conflict errors, because we will need them. And then we are going to import our user service we just created earlier. Here we go. Let's start creating our controller. This time I don't create a class, I create a module. It's fine. Whatever is okay. So basically, so we are going to start with the user, getting all the users. So it is request. With TypeScript, we define the type of every parameters, make things clear. TypeScript is really good for documenting our code. It's not only about documentation, it's also it will compile and throw an error if there is a potential error when compiling. But for the last 5 years, I haven't seen any project without TypeScript, and it's really convenient. Yeah, it takes more time, but actually, after the maintenance, it makes things so much easier for the maintenance. TypeScript is a must to have. And so basically, next function is here. Promise void, and here we go. Now we are going to try to get the user. So get all users, and I want him to send back a JSON file. So basically, this is the HTTP request. You have the request, you have the response. You can specify what you want within the response, and I want to wrap my user as a JSON, so it will transform as a JSON and send it back. So it's gonna be 200. It's a success code 200. If I don't specify the code, it will be 200 by default. Catch. Now we are going to catch error if there is any. And the error could be sent from the database, for example. We could have a connectivity issue between the model, between our Node.js application and the database connection. So there is many reasons why we could have potentially an error, and we must handle those errors nicely and send back the appropriate error code to the client so that he knows what's going on. In case of database error or in case of connectivity error, the error code would be 500. It's a backend error, basically. It's not like a business related error. So now we are going to next error, meaning that when we say next, it means that the next middleware, I will talk about the middleware after. The next function to be executed and through, because our requests come to the API, it will go through the controller service and so on. But then also there are some middleware that go through, and then finally the response will be sent back to the client. So as part of the middleware, we have an error handling middleware that makes sure that there is no error. All the errors through from the application are caught, and then the appropriate error code is sent back to the client. Now we're going to implement getUserById. Same function. Actually, I should just copy paste. It's gonna be so much quicker. I type it because this is for the purpose of this interview, but of course I will reuse the code as much as possible, so that implementation is quicker. So whenever we implement this function, we are going to get the ID. when you get user by ID, so the ID is provided to the query through an ID parameters, and we can get these parameters from the request parents objects. Once we have the ID, we can finally get the user. And we are going to send back the user. And we are going to reuse the same. There is nothing specific here. Alors, what are we missing? So basically, it's waiting because it's a module, so I have to separate my function with comma. Now we are going to create the user. It will be the same function definition. We are going to do the same for the update user and delete user. Here we go, we have all our functions. For the user creation, basically, in this particular case, we don't send back a simple 200 code. The RESTful HTTP, the standard once has to send back a success code 201 to say the resource has been created. So to do so, we specify res.status 201. Here we go, and we want the user to be sent back because it's a RESTful API, and whenever we create or update a user, we must send the created or updated data to the client, to the caller of this API. So now earlier when we created the user, we go to the model, the service, the user service. Where is it? Okay, we have specified we have a specific error we actually threw, right? This is a unique violation errors. So here we need actually to handle this. So we actually we can just text through it. It's not gonna change anything because there is no specific operations to do. We already have defined it as a conflict error, so there is no issues here. So we have a user service and we are creating a user, and I realize that this is capital C and it should not be a capital letters. It's not following convention. So we are going back to user controller. Here we go. Now let's go with the update user. We will have the same ending. Try catch. And within it we are going to have this guy, we are going to get whenever we update the user, we get the ID from the parameters. Then we have to update the user. And it requires an ID. And it requires a user. The user is provided inside the request body. And if there is no updated user, meaning that there is any issues with the database, the user was not found, then we are going to throw not found errors, user not found. Now we are going to send back this updated user to the client, the front end. And that's it. We are good for this one, and that's the last one, and then we are done with the controllers. So we are going to reuse the same logic. However, here we are going to keep this one. We are going to get back the number of, but actually we don't especially need it, but and if there is no deleted count, meaning the user didn't exist, I think we throw new not found errors. Otherwise, we are going to send a message to the client to say the user deleted successfully. Here we go. We are done with our controller. So currently, this controller is not a class, so we don't need to instantiate at the end. Just exporting it, we can reuse it in our routes. So now, let's talk about the entry point of this API. So we have defined a server. So basically, it is an Express server. Within this Express server, we can apply middleware. So here, for example, we use express.json, meaning that we want the middleware to transform the data within the body into a JSON, so that we don't have to do it every time we want to access the body of a request. So here we are going to define which what are the routes available. So basically, we specify that if the path is as the following, then all the routes will go toward these functions. Also, we will specify the error handling middleware I talked earlier. So we are going to build it later on. Basically, it's just a function that will catch any errors through from one of the routes and make sure that it will send an error code, a nice error message to the client, instead of just sending the whole stack of the errors. We will just send a nice error so that it is user friendly, I would say. So now let's start with this API router. We are going to define a route for our user resources. Let's go within our user resource. So here we are going to have, actually we are going to have one routers or one routes per resources. So one for the user, one for the project, and one for the task. Let's start. No, for example, we need the routers. And we are going to import user routes that we have not yet implemented. It's gonna be in the same folder. We are going to instantiate our routers. And within this router, we specify that whenever we have /user in the path of the request, we want this request to be thrown to our user routes. We will do the same for the other resources, project and task. So it's gonna be user root, project routes, task routes. We have not implemented them yet, so that's why we see an error. So now let's start implementing the user root. So basically, it like earlier, we are going to specify to instantiate the routers. We are going to import our user controller. Here we go. And let's instance it. And now let's create our routes. So the first route will be get all users, right? So when we say get your users, we rehearse that whenever the method of the request is a get, and the parameters, the path is a /, that means we are not specifying any IDs, nothing, just we want all the users. Basically, just before we said, okay, if it is /users, please go inside this user routes. Now inside the user routes, if it is a /, then it means we want to get all the users. So we are going to specify the function we want to call, which is get all users. We don't specify. Here we go. We have our first routes. Now let's define get a user by its ID. We are going to do it a bit more quicker. So for the ID, we are going to specify the parameters inside the path. Express will understand that this ID is actually what is in the path after the /, and will instantiate and consider it as an ID and provide it as a parameters. So here we will need to do some data validation. So basically, when we are going to use a library called Zod for data validation, we are going to create, for example, we'll have what we say common validation, and we will have our user schema validation. So in regards to the common validation, meaning that this validation can be used by other entities, other resources, like project or user. So first of all, we are going to import Zod, which is a common library to for data validation. Really famous, really convenient, really useful. And we are going to reuse what we have in our controller before, which is same here. Valid date id param equal. But here the id inside the id param we specify, because we use TypeScript, we have to say what can potentially be the id params, and we specify it can be there is an id with a string. And when doing validation, we are using Zod. So within this object we have an id which is supposed to be a string, which is supposed to be a UUID type. So if you provide a simple string like hello, it's gonna fail, because UID type has its own specificities, and we are making sure that we have a right ID. Otherwise, we throw an error to the client. We send back an error message to the client. So here we go. And if it is not a success, then please send back 400 errors to the client, but we still need to specify that it's gonna be within a JSON object. And then return. Alors, what do we have here? First of all, the request ID string is not generic. I forgot to import the also here. It's a type. I'm importing. Here we go. We are good. So we have this valid ID param that we need to where is it? Specify as a second parameters. Import. Here we go. But we will also need to validate other stuff, but not for this one. Now here we are going to call get user by ID. So whenever you have a root / with whatever, please validate the ID params. Otherwise, if it is good, go through this controller function. The controller function then will get the ID params and go to the service. The service will get the ID params as a parameters and call the model, and the model will finally get from the database and send it back, and then we go back into the chain. So first IP server routes controller service model get the database, and we get back model service controller and the routes, and then we send it back to the client. If there is any errors occurring during the process, we send back an error message to the client. So now we have created the route for the creation of to get a user by ID. Now we are going to create a route whenever we create a user. So whenever it is a post request with the slash, meaning there is nothing behind, it's gonna be interpreted as a creation of new resources, and we will have to validate that the payload of the request is a valid users, and once validated we can call the controller to update the user. So we have not created it yet, but basically we have to create a new schema to validate the user. This is specific to user, so we have a specific file, user schema, that we are going to create. So basically we will take the same, then we have to create our user schema. It's gonna be a Z object. Within it we will have username. Username cannot be empty, so we say specify minimum 3 letters, 3 characters, and then maximum 30 characters. Then we are going to have an email. Email is made. Email was made of how many characters? 250 characters maximum. Password same. So we don't need a min, but because it was not mandatory, but we need a max. And we have the password also, which is max, like this. And but the password actually have also a minimum of 8. Otherwise we refuse payload. This is our schema, and now we are going to validate the user data provided as parameters. So we are going to use the same function. However, here is gonna be regular. There is no specific. If there is no parameters, it's a regular request. Please check the body of my request, and if it is not a success, then please throw a 400 error, and within it otherwise return. Next, otherwise we go to the next middleware. Here we go. and this validate user is used here. Otherwise we validate user, it's not it's create user. Here we go. So now we have a route to create, validate. We will need one to update. So whenever it is a put function and there is a ID parameters, it means it is for it is for update the users. In the case of update request, put request, we have to provide the ID parameters as the parameters. So we need to validate if the ID param is a valid ID params, meaning it is an UUID. And to finish, we will have a last one, which is gonna be delete. Users. And we are good with the route. We are done with all the routes, all the API for the users. And now we are going to test our API. So now we are going to we need to commit the data, new data we have added. So basically we are going to add all the controllers first. We are going to add the error if, because we need them, and the schema, and also the new types and utility. This one, no, now we are here. I'm going to commit it. It's new features. Here we go. We also have created the route. And the middleware and everything. So let's add everything. Implement the route. There we go. So we are going to start our server and test it. So in order to test it, we are going to use a VS Code plugin, which is called Vendor Client. Really simple to use right away. No need to install something specific on our laptop, really convenient. So I have created, in total we have about 15 API endpoint, and I have created a use case, a test for every of them. So it's like Postman, exactly the same thing. You can see we can test get users, post users, delete users, and so on. So we are going to test the user endpoint that we just implemented together. Here we go. So this is a database here. Let's check what we have. We have 3 users, and here is our endpoint. So we are going to test it. So it's localhost. The port is my Postgre through my Docker. Here we go. We got our 3 our 3 users here. Now we are going to take the ID of one of them, and we are going to get it directly through the ID here. And we can get it. Alice, we have Alice here. Now we are going to try to update one of the users. So, for example, this is a valid ID, right? The user exists, but if I put an ID that doesn't exist, we get an error, user not found. So our error handling is working. I'm going to use a real user, and I want to update, for example, but with a username, a name of only 2 characters. So we are going to check if our ZOT validation is working. As a reminder, we check, I'm going to show you the file again, schema, task user. A username must be between 3 and 30 characters length. So I'm setting it up to 2. An error comes. It must be at least 3 characters. Now I'm going to do something really bad and big one. At most 30 characters. So our handling, the tests are working. We are going to use a regular one to test presentation and send. Oh, it got updated. We got 200 OK success error code. Let's check in the database. This one got updated as well, you see. So our put endpoint is working. Now let's check, for example, for the post one. For example, let's say test. So we got a 200 created, and he sent us back the created resources. It complies with the best practice for RESTful API. Let's check in the database. Here we go. We have 4 rows now. And let's finish with the last one. We are going to get the ID of a user we created or we had before. This one. Let's paste it here. Let's check with something that doesn't exist. User not found. Good. And with something that exists. User deleted successfully. Let's check in the database. And the row get deleted. So we are all good with our backend API for the user resources. So we have to do the same for all the other resources. I made them separately out of this video because it would take too much time. But everything is included in my code and in my repository that I will send you the link so you can check.